All right, now the first thing that we want to do in finding this derivative is just rewrite this original equation in a way that's going to be applicable for the power rule. So I'm just rewriting f of x. I'm going to show it out the long way here. So it starts out as 6x to the 5th times x to the 1/2. So I took my square root of x and I wrote it as x to the 1/2. But then I still wanted to get rid of that multiplication. So I don't want it to be multiplication. I have to have it just be a single polynomial term there. So it's going to be 6. And then I have to do x to the 5th times x to the 1/2. When I multiply the x's, that means I add their exponents. So I'm going to have to be doing 5 plus a half, which means I'm going to be doing 10 halves plus 1/2. So that gives me 11 halves. Now you could also have written it as 5 1/2 when you write it here, but I'm going to go ahead and just call it 11 halves. Now once you get there, then you can go ahead and find your derivative. Now I'm going to stick with the same notation that we have up here, the df over dx. So I'm going to say df over dx equals here, and then go ahead and find the derivative at that point. And so to do this derivative, I'm going to use power rule. So I'm going to be doing 6 times my exponent, so 6 times 11 halves. And then it's going to be x to the, we need to subtract 1 from that.
9 halves.
And so 11 halves minus 1, that's the same as 11 halves minus 2 halves, which is 9 halves. All right, and from here it's just a matter of cleaning that up, because while technically that is the derivative, it just needs to be cleaned up a bit. So we're going to do df over dx equals 6 times 11 halves. Well, 6 divided by 2 is 3, and 3 times 11 is 33. And then x to the 9 halves. Well, 9 halves is the same thing as 4 1/2. So notice, that means I can pull out 4 wholes, but I still have x to the 1/2 left. And of course, x to the 1/2 is just the square root of x. So it's going to be x to the 4th square root x as our final answer. That is the fully simplified form, at least. And yes, we do want to keep moving toward that fully simplified form as we go. Now, in order to use power rule with this one, remember we're going to have to take our one big fraction and turn it again into 3 separate polynomial terms. So take each of those 3 individually and put them each over the 4x cubed, and then simplify each before you take the derivative. And so when you do that initial step of just simplifying it down into 3 separate polynomial terms, this is really the equation that we're finding the derivative. So now that you have it there, now go ahead and find out what f prime of x would equal. And so when we take that derivative, this is where we end up. And so notice we only have 2 terms left, not the 3 that I had to start, because when we find the derivative of a constant, that equals 0. And so that just falls out, it disappears. And so the other thing to note here is that when I multiplied 1/2 by the -2, that gave me -1. Hence why there's no number out front, but it is now subtraction instead of addition. All right, this is your derivative. It is technically done at this point, but we have been talking about cleaning things up a little bit, so let's see how we would go further in this problem and actually clean that up a bit. Try to make it look more like the original. So I got f prime of x equals, and I have this x to the -3rd, which tells me that I want to be able to end up in my final answer with an x cubed in the bottom. All right, so then, how do I accomplish that? Well, I got the x squared here. That means that's going to have to become an x to the 5th. And then minus, well, that would just be a 1, right? But you notice I skipped over the 15/4. I don't really want to write 15/4 in the top of my fraction. I don't want that to be a fraction within the fraction. I'd rather that just be a 15. Well, what's that mean? That means the 4 would have to be down here, but if that 4 is there, then this is no longer just a 1. It means that would have to be -4. So then if I took and simplified that, it would still give me just 1 over x cubed, which is what, of course, this means. And so that would then be considered our actual simplified form of this one if I tidy it all up into the single fraction like we started with. All right, now if you started this one the same way that we started the last one, you're going to run into some trouble here, right? Because if we just split it up into the 3 separate fractions represented by the 3 different terms on the top up here, you notice the problem is that I can't really simplify any of these just into polynomials anymore. It's now 3 rationals instead of 1 rational. This did not actually help us. And so we're going to have to take a different tactic than we did last time. But it is still going to start in terms of rewriting what f of x equals. In this case, though, we can rewrite what it equals by simplifying the original rational. Notice that this does factor. So please factor it in order to simplify it, and then we'll go from there. And so we factor. And when we factor the top and the bottom, you'll notice that we do have a common factor in there. We have that x minus 2 appearing twice, so that can cancel out. And so then, f of x here is just going to equal 2x minus 3 all over 2. Or if we want to make it nice and easy for us to be able to do the derivative, I divide both of those terms on the top by the 2. 2x over 2 is x, minus 3 over 2, which is, well, 3 over 2. That's really what f of x is. Now that I have that, I can then go on to finding my derivative, the f prime of x that we were asked to find in the first place. And when we do find that derivative, the derivative of x is 1, and the derivative of negative 3/2 is 0. So our final answer is that f prime of x equals 1. Now the first thing we do need to do is we need to try to simplify this. We need to try to factor it down. And so the very first thing that I do is I tend to look for the easiest one to factor, which for me in this case is the denominator. Because there all I have to do is pull an x out of both terms. So that's going to become 3x plus 7. And part of the reason why I like starting with that easier one is because the goal is that I really can only find the derivative of this if it does simplify. The only way it's simplifying is if I can cancel out a 3x plus 7. So I'm going to start by factoring out the top by guessing that 3x plus 7 is one of my factors. And if that is indeed the case, to get the 33, I'd have to start the other one with an 11. And to get the negative 35, I'd have to end the other one with a negative 5. So then let's check. If I now multiply the 3 and the 11, oops, not the 3 and the 11, the 3 and the 5, that gives me negative 15. And the 7 and 11 gives me 77. Is 77 plus a negative 15 going to give me 62?
Yes.
Yep. So that does work. That is my winner. Those little clues can help you factor these a lot faster. And so because of that, I can cancel out those 3x plus 7s, and now I have my starting equation as just 11x minus 5 all over x. Now, it still isn't at the point where we're going to be able to find the derivative straight away, so we still need to tweak that form a little bit. I'm going to take each of these two terms and put them over x. So 11x over x is 11, minus 5 over x, and I want to be able to do the derivative, so I'm going to write this as 5x to the negative 1. Once I'm there, I can now go ahead and find g prime of x, which is what we're asked to do. And so to find that derivative, we first find the derivative of 11, which is 0. So that part's nice and easy. And then when I do the derivative of negative 5x to the negative 1, I start by multiplying negative 5 by the negative 1, which gives me a positive 5. And then I subtract 1 from my exponent to get negative 2. And this is okay. If you give this as your final answer today, I'm okay with that. But within a couple weeks, it's going to have to be cleaned up. So let's talk about how we clean it up. That x to the negative 2 tells me that it's going to flip it into the bottom of the fraction. The 5 does not have a negative exponent on it, though, So the 5 stays on the top. Therefore, this would be our ideal answer. So step 1 is to simplify and turn it into polynomial. And so I take each of the 3 terms on the top and I put them each over the 2t to the 4th. Yes, keep them t's, don't just start calling them x's for fun. And then we take each of those 3 terms that result and we simplify each one of them, writing each one as a polynomial. So leave that as a negative exponent there. Now that you're there, you can go ahead and find your derivative. So you're going to go ahead and now find the dh over dt, which, remember, notation-wise means the derivative of h with respect to t. That's what we read that as there. And so here is our derivative, and yes, it's okay today if you got just to this point, but we want to push it further. Once you get here, try to now write your answer as a single fraction, the same way that the original was formatted. All right, so in terms of doing that, in terms of turning this now into a single fraction, well, the easiest way to visualize it probably is to start by thinking of it as adding fractions and looking for a common denominator. So I'm going to go ahead and go down that road here. So the dh over dt is going to equal, well, looks like I'm going to have 2 fractions. I only need a common denominator of t squared, so I don't have to mess around with that second one too much. For the first one, though, if that's going to be over t squared, that means I have to multiply top and bottom of this fraction, and yes, it's a fraction because it's over 1, by t squared. And so if I multiply that top by t squared, that becomes 12t to the 5th. And now I can go ahead and do that subtraction. So dh over dt is going to equal the 12t to the 5th minus 10 all over our common denominator of t squared.